Read the question first. The energy grade line is 2.6 for a Weir. So it's a type of Weir question. Above the channel bottom. So that's a Weir. Probably something like that. That's the bottom. The energy is here. So E is equal to 2.6 meter. And the water will pass through this. The 1.4 meter high Weir. So that's the Weir high. And it has a 5 meter width. And it's a rectangular channel. And the discharge is 10 cubic meter per second. It asks for actual coefficient, and it says that it's not 1.7, which is a normal coefficient. And considering the energy loss. So you should consider it. Also determine amount of the energy loss in meters. So it seems that you need to find the energy loss as well. The two things that it asks. Let's get rid of this one. Okay, here we go. I need another page here. That was question 1. On a slide here, question 2 on a slide here as well. Okay. So the energy was 2.6 meter and B was 5 meter. I will write Y, which is off here. Q was 10 cubic meter per second. It asks for CD and HL. If you remember for Weir, we had C, L, H over to 1.5. I have 10 for discharge. I'm looking for CD, let's say. L is the same as B. It's the width, right? So 5 multiplied by, what is the H? Again, I'm going to show it to you here. That's 1.4 meter. The water passing, you don't have it, but you have the total energy here, which is 2.6. So the difference between them is your H. H is the water above the crest. Crest is this point. So if I have a total of 2.6, 1.4 for the high of the Weir, the rest is yours as the head of water. If you calculate CD, you will have 1.52. It asks for the losses. When talking about losses, there is no way than using energy equation. I will say that this is 1, this is 2. E1 should be equal to E2 plus HL, the normal Bernoulli equation. Do I have E1? Yes, exactly here. It says that it's 2.6. I don't have E2. But do you remember that at the top of Weir, we use them as a control point? It means that something's happened there. It means that you can see critical situation there. So I can say that this is EC plus HL, critical. Now I need to find critical energy here. Do I have anything in my hand? Yes, the easiest one, if you remember, was 1.5 of YC. Do I have YC? No, but again, I have another small equation to YC, to find YC, this one. Q2 over G3. Do I have a small q? A small q is always Q over B over G3. I think I have all info right now. Square. Is it metric? Yeah, so 9.83. My YC is this number. Write it here. Um, 0.74, which is around 1 point. So 2.6 here, 1.1 here plus HL. It seems that I have everything, but don't forget one thing here. Look at here, I have energy here. I have this H here as well. But if you, like energy, not head, this is the total energy, so I have both. But I should consider this Y as well. This is the depth of or the height of Weir. So when you are writing Bernoulli, don't forget this one. You have this at the top of that, you have the energy of water. So this is two part. So this should be equal to this one or energy of this one. So this 1.4 is the depth of Weir. Then on the top of that, you have energy of 0.2 or critical energy. If you write it all, you will have a very small amount of losses, which is 0.087 meter. That's all. So energy at 0.1, EC or E2 here, but you have a solid things here, which is 1.4. Don't forget that size. So for CD, I will write the original equation. Easy to do that. Just be careful, you need the head on the top of that. I have the total of 2.6. This one should be deducted. Everything above that is H. Then for the losses, I will write the energy equation. When I write that, E1 is done. E2 is a control point, so critical happens there. So I use all the information for the critical situation to find the EC, which is equal to E2. I'm done, but don't forget that you missed 1.4 as a high of the Weir, then on the top of that, add that.